Good morning, students. As you have referred the step-by-step procedure of problem 2, how to solve in the AutoCAD. Today I will be explaining with the live using AutoCAD how to solve the problem 2. So just I'll read the problem. Draw the sectional plan and elevation of the core of a single-phase transformer with the following details. So till now, whatever problems we had done, we wrote only the sectional plan. Now we also have to do the elevation of the sectional plan. So what I'll be doing is, to avoid the confusion, first I'll be solving only the sectional plan. As we have solved two problems of sectional plan, I'll solve the sectional plan. Then the second part, elevation, again I'll be explaining. So we'll see the details. It is a three-stepped core. Diameter of the circumscribing circle is given as 22 centimeter. And also distance between the core centers is given as 35 centimeter. Height of the core 48 centimeter. Height of the yoke 25 centimeter. So these two are required for the elevation. Your height of the core and height of the yoke. Show the general arrangement of HV and LV windings, taking suitable diameters of the windings. So here you can observe the inner LV, outer LV, inner HV, outer HV diameters are not given. We have to assume suitably. Okay, so this should be assumed suitably. So as I told you, I have given this in the notes also. So till now what we are doing, this was the horizontal cross section of the sectional plan we were doing. Now in addition to the sectional plan, we also have to do the elevation. So in the elevation, we require the height of the yoke HY, height of the window or there is height of the core is given, then again height of the yoke. So now we will try to do the calculations. So it is given in the problem as a three-stepped core. So as it is a three-stepped core, we will have three steps A, B and C. The formula is length of the largest stamping is 0.9 times diameter of the circumscribing circle. Length of the middle stamping is 0.7 D. The smallest stamping is 0.42 D. So once we calculate, we will get it as 91.8 centimeter. So if I multiply by 10, I'll get 198 mm. Length of the middle stamping, I'll get it as 15.4 centimeter. Into 10, 154 mm. Length of the smallest stamping, I'll get it as 0.42 into 22, 9.24 centimeter into 10, 92.4 mm. So first and foremost step is we have to draw the stampings A, B and C. It is a three-stepped core. Here as the inner LV, outer LV, inner HV, outer HV is not given, we have to assume it suitably. Here I am assuming it as 24 and 26 centimeter for inner and outer LV. For inner and outer HV I am assuming it as 29 and 31 centimeter respectively. So I will tell you how to cross check this again. So this is random, you can take anyhow. Okay, this is the three-stepped core. So here they are showing right half in section, left half is not in full section, it is projection. But in the question we have asked, draw the sectional plan and elevation, full we have to draw. So whatever is in the right, same thing should be put to the left. Same thing should be copied to the left portion. Now we'll open the AutoCAD software. Once you open the AutoCAD software, check whether you have selected the AutoCAD Classic. So already AutoCAD Classic has been selected. What will be the first step? You have to set the units. Type units in the command prompt. This decimal precision, you take it as 2 decimal places. Insertion scale millimeters. Okay. Next you go to the limits. Enter. It is asking specify the lower left corner. The 0, 0. Upper right corner 297, 210. Now I have set it for the A4 size paper. Next zoom all, Z enter, A enter. So now this is my screen with A4 size paper. So we'll see the calculations. So what is the diameter of the circumscribing circle is given in the problem is 22 centimeter. So 22 centimeter means 22 into 10. You have to take it as 220 mm. Okay. So the first circle what I am going to draw is a circle of 220 mm. Go to the circle. Specify the midpoint of the circle D. Because I am giving diameter, D enter, 220 enter. So I will be getting the circumscribing circle, which is of 220 mm diameter. So you can shift it accordingly wherever you want. So this is the 220 mm diameter circle. Now for this circle I have to draw the stampings. See here. Length of the smallest stamping is 92.4 mm. So switch on the ortho. Take a line and draw a line of 92.4 mm. Once I draw this line of 92.4 mm, what I am going to do is select this line, move this line, take the midpoint, move it exactly to the center of the. So this is my smallest stamping, 92.4 mm. Now draw the horizontal lines. This is my smallest stamping, 92.4 mm. Next I'll go to the middle stamping. Middle stamping is 154 mm. So follow the same procedure. Take a line, draw a horizontal line of 154 mm. Select the line. Move the line such that the midpoint of the line is placed exactly at the midpoint of the circle. Repeat the same procedure. Extend the vertical lines. See, there is no rule that you have to follow the same procedure. you have any other shortcut method, you can use that shortcut method. Now I have drawn the two stampings, smallest stamping and largest stamping, middle stamping. Next is the largest stamping, 198 mm. Follow the same procedure. Take a line, draw a horizontal line of 198 mm. So select it, move the line, select the midpoint of the line as the base point and place it exactly at the midpoint of the circle. Now draw the vertical lines. So now we have completed drawing all the three stampings. So this portion is over. Now whatever additional lines are there, we have to trim those additional lines which are beyond the circumscribing circle. Go to the trim option, right click, left click on the lines which are to be trimmed. So you can also delete the middle line. That's the stampings. You have three lines there. All those you can delete. After deleting this, now we are going to draw the stampings. Join horizontally. So this is how you are going to do. So for each stamping, the vertical lines which I have drawn, we have trimmed all the lines which are outside the circumscribing circle. Now for each vertical lines, for each stamping, this is for the smallest stamping, join the horizontal lines where it intersects the circumscribing circle. Now we have to trim the inside portions. Go to the trim option, right click on the portion which you want to trim and remove. Trim the extra portions. Now you can observe I am getting the perfect three-stepped core. 1, 2 and 3. 3 steps are there. This is the smallest, this is the middle, this is the largest. This is about the three-stepped core. How to draw the three-stepped core. So we have finished with the first step wherein I have drawn the three-stepped core. Next I have to draw the inner LV, outer LV, inner HV, outer HV to complete the sectional plan. So one more important thing which has been data which has been given is distance between the core centers is 35 centimeter. Now I have assumed the outer HV as 31 centimeter. So diameter is 31 centimeter, that is 310 mm. The distance between the core centers is 350 mm, 35 centimeters, 350. Now how to cross check? Distance between the core centers is 350 mm. So from here I'll take a line of 350 mm. So this line is 350 mm. Again from this center, the circle should start one more section. Distance between the core centers is 350 mm. So what is the half of 3? Half of 350 is 175. It's the midpoint here. So I should choose the diameter such that it should not extend this line. So I have chosen the diameter of outer HV as 31 centimeter, that is 310 mm. So 310 divided by 2 will be 155 mm radius. So 155 mm means from here to here it is 175. So 155 will come somewhere here, it will not overlap. That is how I have to check whether the inner LV, outer LV, inner HV, outer HV diameters have taken correctly. Okay. Check for the outer HV. That is an important thing, how to cross check. Now what is my next thing I have to draw? I have to draw the inner LV. Inner LV is 24 centimeter, that is 240 mm. So go for a circle, take the center of the circumscribing circle, and as it is diameter, D enter, diameter is 240, 240 enter. So this will be my inner LV. Now I can name it. Circumscribing circle I will give the name as A, inner LV I will give the name as B. A and B. Go to the single line text, draw text, single line text, and you can take it as 5 enter. It has A and B. Now we can increase the scale. So this is my B. Similarly, for A, go to the scale, increase the scale appropriately. Or you can just leave this, copy the same thing, paste it, double click on that. Now change it to A. So now we have got A and B. A is the circumscribing circle, B is the inner LV. Now draw the hatching between the circumscribing circle and the inner LV. Go to hatch, any pattern you can use. Go for add select objects, select the inner LV and the circumscribing circle, press enter. Scale factor you can change it here only, or afterwards also you can change it to 6. Okay. Further, if you want to change the scaling, you can select the hatching pattern, right click on the hatching pattern, go to properties, you can change the scale. If you want to further increase it to 8, you can increase it to 8 and close it. So this is how you are going to do. Next I will draw the outer LV. Outer LV, the diameter is 260 mm and we have to name it as C. So go for the circle, center of the circle, D enter, 260 enter. So this is my outer LV. So copy this B, here and name it as C. Double click on this. See, once you do any one single line text, same thing you can copy and paste so that the font will remain same. Again and again scaling is not required. Now this completes the LV winding. There is B and C. Together this portion is the LV winding. Now we will go for the HV. So inner HV is 290 mm. Take a circle, take the midpoint, D enter, 290 enter. So name it as D. Select the C, copy the selection. You can place it here. Double click on this and change it to D. So D is the inner HV of 290 mm diameter. Now we will draw the outer HV, 310 mm diameter. Take a circle, take the center of the circle, D enter, 310, 310 enter. This is my E. Copy and paste. So we have completed the sectional plan of one limb. Where we have the 3-stepped core. A is the circumscribing circle, B is the inner LV, C is the outer LV, D is the inner HV, E is the outer HV. So So as I have not told anything about the oil ducts, you can mention the oil ducts or just you can hatch the LV and HV with different colors, or you can go for the gradient. That is left to you. So that is left to you. You can place the oil ducts or do the hatchings or gradient, whatever is required you can do. So I'll be writing the oil ducts. So oil ducts will be between C and D, that is outer LV and inner HV. Take a line. Switch on the polar. Trim the extra portions. Now do a gradient or hatching, that is left to you. Now I'll go for the gradient. Add pick points. Within the oil duct I'll select. I'll press the enter. Color is left to you. Any color you can choose. If you want green oil ducts, you can use green. If you want pink, whatever is your option. So you'll get the corresponding oil duct. Again I'll repeat. Switch on the polar. And between LV and HV, between circle C and D, draw two lines. Trim the remaining portions and do the gradient. Now you can do the array. Now go for the array classic. Go for the polar array. So it is asking the center point. What you have to do is click on this arrow and select the center of the circle. It will take the corresponding coordinates. Methods and values. The method which I am going to use is total number of items and angle to fill. As it is a circle, angle to fill will be 360 degree. Total number of items depends on the number of oil ducts I require. If I require 4, it is 4. If I require 6 oil ducts, I will make it as 6. Now go to the select objects. So while doing the select objects, you have to be very careful. You have to select the entire oil duct. Press enter. Press OK. So now we have got the 6 oil ducts. So this completes the sectional plan of one limb. So as you know that the single phase transformer will have 2 limbs, we have to draw one more limb. It can be either on the left side or on the right side according to your convenience. Now what I am going to do, as the distance between the core centers is given as 35 centimeter in the problem, 35 into 10 will be 350 mm. So I'll draw a line of 350 mm, either on the right or left, that is left to you. So now switch on ortho, take a line of 350 mm, 350, enter. Now the same portion has to be repeated here. So what you are going to do is, you are going to select the entire portion. You have two options. You can go for the mirror option or copy and paste. I'll show both the options, whichever is convenient for you, you can do that. ensure that all the things are selected, nothing is left here. All the things are selected. Go for the copy selection and take the center as the base point. So the second base point will be the end of the 350 mm line. As I had selected the 350 mm line also, so I can delete that line. So this is my sectional plan, full sectional plan of the transformer. So what is the next option? I told you can go for the mirror option. For the mirror option, take the midpoint of the 350 mm line, draw a vertical line at the midpoint of the 350 mm line. Now go for the mirror option. MI enter. Select the objects. You have to select all the objects including the hatching pattern. Or better, first you can select all the objects including the hatching pattern. Go for the mirror, MI enter. Glass, select the first point on the mirror line. Select a point on the vertical line which is at the center of the 350 mm. Second point to select. As I told you, it is asking erase source objects, yes or no. You make it as no. N enter. So this is the sectional plan of the transformer. So as I told you, once the core center distance is given as 350 mm, you have to choose the outer LV diameter carefully so that these two circles will not coincide. So this completes the sectional plan of the core type transformer. So I'll be stopping now. So in the next video, I'll be explaining how to draw the elevation from this sectional plan.